Hello everyone, this is Henny and welcome to my channel. Today I'm going to start the 5th lecture of the course MATLAB for Beginners, and today we're going to cover the conditional statement with examples. More specifically, we're going to cover the if statement and the switch statement. First, we're going to have some theoretical discussion about both of them, and then after that we're going to have more practice examples using MATLAB. So let's get started. The if statement is used to perform some actions or to run some statements if some conditions are true. This is a structure of the if statement. So we have if, this is a keyword, and we have end is a keyword as well, and then we have a condition, and we have to put the condition in parentheses, right? So we can say if condition, and this condition is evaluated to true or false, or 0 or 1. True or false are corresponding to 1 and 0. So true for 1, 0 for false, or false for 0. And then if this condition here is 1, or this condition here is true, the statements are going to run. Otherwise, no statements are going to run here, no matter how many statements, right? So if condition is true, statements are running, and then end. If condition is false, statements are not going to run, and we end this statement. Now, when we speak about statements, statements are complete instructions that are given to the computer. So this statement must be complete statement, this statement must be complete statement, and so on. If a statement as well, this is a multi-line statement, right, that includes some statements inside, but still it's a statement. So it must be complete, and to complete it, it has to have this structure: if, condition, statements, and end. This is a very basic structure of the if statement, and we have other forms of the if statement, especially when we have more than one condition. For example, if we have two conditions, we might add the else if keyword. If condition 1 is not true, those statements are not going to run, and then the program stops at the else if and then checks if the condition for the else if is true or false. If it's true, these statements are going to run. If it's false, nothing is going to run, and we end the if statement. So this is another form for if statement, and we can add else if with a condition or more than one else if, and we can add the else keyword like in this structure here. So for this form of the if statement, we test this condition. If it's true, run these statements. If it's not true, try the second condition, and if it's true, run these statements. If not, try the third condition with the else if. If it's not, and if we do not have any condition that is being true, then else. Else here means if all the conditions are not true, run these statements. So this form of if guarantees that some lines of codes are going to run, or some statements are going to run, because if all conditions are not true, no statements here are not going to run, then else run these statements, and then we end the if statement. So this is a very general form of the if statement, and you can remove some else if or the else as well, according to the problems that you have. And now we switch to the switch statement. The general form is just like this: switch, case, otherwise, and end are all keywords. It works this way: we have switch, and then we have a variable name. So we can say, for example, switch x, and then case. After the keyword case comes the value of the variable. So for example, if this variable is a grade of a student, right, and contains 85, let's say, okay, so we say switch grade. So variable name is grade, switch grade, and then case. If it's 90, then run this statement, this statement, this statement, and so on. So we say here case 90, and then if it's not, check the other case, case 85, and so on until we end up with the otherwise keyword. Otherwise keyword says basically if none of the values here equals to the value in the variable, then run these statements, and then we end the switch statement as before. Now the main difference between the if statement and the switch statement is that the switch statement does not check anything other than equality. So we check this variable if its value equal to one of those values. We cannot check in switch statement if it's larger than or smaller than or does not equal. This is the main difference, but sometimes it's better to use the switch statement when we have something like multiple choices. So that's it for the theoretical background, and to understand the if and the switch statement, it's better to have more practical examples. So let's switch to MATLAB and try some examples. So now we have MATLAB, and we're going to run some examples. First, I'm going to run a few examples here on the command window to show you that you're able to run if statement and the switch statement on the command window, even though the if statement is multi-line statement. And then we're going to run the statements in a script file and then a function. let me first show you how to run multi-line statements in the command window. So in the command window, to write your statement in multi-lines, you have to add the 3 dots here. So when you have the 3 dots here, it means your statement is not ending in this line, but it ends in the coming lines. Okay, so you can just say, for example, x, and then the assignment operator, and then 3 dots, and then you write here 5, right? So when you do that and then enter, then x assigned 5, right? But if you say x assigned and then enter, this is wrong. So having 3 dots allows you to extend your statement to the next lines. Now, the second thing I want you to know is the logical variable. So from the previous lectures, we know that we have double variables. So x is 1 by 1, and it has a double data type. So the data type is double. We have a different data type called logical. So logical here is corresponding to Boolean. So in other languages, it's called bool or Boolean. It's basically 0 or 1. Okay, so 0 for false and 1 for true. And you can use variables of this data type in different situations or different applications. But here we're going to use it in the if statement. Let's say, for example, x, this is a variable, and you want to assign it 1 or 0. So you can say x assigned 1, this is double, or x assigned 0, it's double. Okay, so now x is doubled, still double, right? Now I want to store variables in x that are logical. So we have to give it an expression that is evaluated to a logical variable. So to do this, we can just say x assigned, and here inside this bracket, I'm going to have a relational operator. Okay, we didn't cover them yet. We're going to cover them today. So one of the relational operators is the equal equal. So equal equal here means we check if this value to the left and the value to the right are equal. So this statement here is a question, and the answer to it is the value. Does 5 equals to 3? This is what it means by this statement. Does 5 equals to 3? What is the answer to this? 5 does not equal to 3. So this is not true. This is false. So this expression here is evaluated to 0. And since the value 0 is coming from a logical expression, then the value is going to be stored in a logical variable, a variable of data type logical, not double. So I am claiming that x equals to 0. Why? Because 5 does not equal to 3, and the data type of x is going to change to logical, right? So let's see. So x is logical and it has 0. Now the logical expressions are used inside the if statement in the condition. So x, I'm going to assign it 5. We can say f and then the condition. The condition is inside the brackets here. So this condition is a logical expression. Logical expression means that we're going to ask a question, and this question, the answer to it is going to evaluate to 0 or 1, and 0 is false, 1 is true, right? And then we are going to continue our statement in the next lines. So I'm going to add this, right? Now let's get back to the condition. So what's the condition we're going to check? Let's say check if x is less than 6. Okay, x less than 6. And this is the second operator here. So we covered the equal equal, this is the equality operator, and then we have the less than, this is the second relational operator, right? So if x is less than 6, then run the following statement, and then the following statement could be x assigned x plus 1, and then we can display x, right? And then we end. So what we have here, we have the if keyword, the end keyword, and we have a condition inside the parentheses, and then we have 2 statements. We can have more than 2 statements. We can have 300, 400 statements. That's fine. This condition is a logical expression that has the relational operator less than, and this expression is a question. The answer to it is its value. So the question is the value of x less than 6? What is the value of x? 5, right? So what is the answer to this? Yes or no? It's yes, because the value of x, which is 5, is less than 6. So this is evaluated to what? To true, or in MATLAB, it's evaluated to 1, right? So if it's evaluated to 1 or true, the statements are going to run, otherwise the statements are not going to run. So I'm claiming that the statements here are going to run. What is the first statement? X here, this is a new X, is assigned the value of X that we know, which is 5, okay, plus 1. Okay, so 5 plus 1 is 6, so X is going to be assigned 6 now, and the value of X is going to be displayed. What is the value of X now? 6, right? So let's see, X assigned 6. Now let's have another example in which we have the else F. So we have F statement with else F. Let's create a new script here. So new script file, we can name it f_script, okay, right? So this is our script. I'm going to clear my screen, CLC, and then let's write some statements here. Okay, so remember, script file is different from function. A script file does contain all the commands that you can write on the command line, but they can run all at once. Okay, so if you have 100 commands or 100 statements are going to run at once when you click on run. Let's first write some documentation. I'm going to show you a nice feature for this editor here. When you right click and choose from here, insert a section, right? It's going to create a section for you and you can write inside it. So basically you can divide your script file to multiple sections if you have several problems that you are going to run. And the problems that I'm going to solve now is the quadratic equation. Ax squared plus bx plus c equals to 0. And the solution of this problem is very known. Okay, so we have two roots for this equation, or two solutions. This is the first solution to this problem and it's very known. You can check it in any math book, so x2 or even Wikipedia. And the second one is going to be very similar, except here that we have negative or minus. Okay, so what is p? P is the number that is multiplied by x. What is a? Is a number that is multiplied by x squared, and c, this is the number here. Okay, so the solution x1 and x2 are just like that. We need to compute x1 and we need to compute x2, right? In this problem we might have a situation in which p squared is less than this term, okay, for a c. If this happens, the square root is going to be computed for a negative number, and if we do that, we are going to move from the real domain to the complex domain, right? So we want x1 and x2 to be real. So to do that, we can check first if p squared is less than this value. If so, then skip this solution and say there is no real solution for this problem. So first I'm going to use the input function. Okay, so input, and I'm going to ask the user to enter some text, and I'm going to ask the user to enter the value of a and b and c. So a equals to enter the value of a, right? And then I'm going to copy that and use it for b and c. If you are not sure about a function in MATLAB, if you see it in MATLAB, or if you want to know more about it, you can select it and then right click here and then help on input. So if you do that, you're going to see some kind of documentation on the function input. So input, it's a function that takes an argument, and this argument is a string, okay, or text. When it runs, it waits for the input from the user, and this input is going to be assigned to the variable, right? Let's first check it if it runs. So let's run this. So it asks to enter the value of a, and we're going to write, for example, 2, and the value of b we're going to say 1, and the value of c is going to be, for example, 0. Okay, so it works fine, and then we can continue, and we can add a section here. We can have inputs, okay, and we can add the third section, computations. Okay, and then we can have this equation. This equation is written in a good way, so I'm going to copy it and have it here and remove the comments. Okay, so square root is a function in MATLAB. If you're not sure, selected and help. Okay, we need to fix this. 4 must be multiplied by a, 4 must be multiplied by a. Okay, to be safe, let's add this here and this here. It's not very safe. We know that p is a scalar variable, so when we call the power on b, it's going to be the power that we know. Okay, it's not the power of a matrix. If you're not sure what I'm talking about, just review the last lecture on operators, right? So this is our equation, and that's it, okay, for this script. So if we run it, so a is going to be, let's say 1, b it's going to be 3, and c is going to be 5. So what is the value of x? x1 and x2 here. Now we have imaginary numbers. Let's see, a, b, and c, right? So the number in the square root is negative, and that makes the whole number here being complex number, right? So to solve this, we can try another example, okay, in which we make sure that b squared is larger than 4ac. Let's run this program again. Okay, so it asks us about a, so I'm going to give it 1, and for b it's going to be 5, and then for c we can have 3, for example. Then the square of 5 is going to be 25 here, okay, and 4 times 1 times 3 in here is going to be 12, so that's fine. So let's run and check x1. So that's a real number, and x2 is a real number. Now our program does have a defect, okay, so we need to make some corrections so that we do not have complex numbers. Okay, so the first thing we need to check now that b squared must be larger than 4ac. Okay, so we could have another section here, let's say testing inputs, whatever. Okay, and then in here we need to write the if statement. The very simple form is going to be like this: f, and then the condition here, and then some statements 1, 2, 3, and then end. Okay, what is the condition now? The condition is a question that we need to answer, and the answer is evaluated to 0 or 1. If it's true, it's going to be 1. If it's false, is evaluated to 0, right? So what is the question here? Is b squared larger than 4ac? Okay, so we write this here. We say if this is true, then we can write the solution here. But I'm going to write it in a different way. I'm going to say if this term is less than this term, then write a statement. Display there are no real solutions to this problem, or to this equation, right? But in this example here, after we finish this if statement, this is going to run again. Let's try it, okay? And let's remove the semicolon to see the result, okay? Now MATLAB does not like it that b is a scalar, and I'm using this dot here, so I'm going to remove it. And also MATLAB does not like display. It asks me to use desp instead, so I'm going to use desp here. So whenever you have this line here, the warning line, try to read what it says. So here, for example, says it asks me to end it with the semicolon. Okay, so it says here, terminate a statement with a semicolon. I don't want to end it with a semicolon, just to show you the values of x1 and x2. So let's take an example in which we are going to generate complex numbers. The script's name is f script. So I'm going to give a as 4, asks me about b, I'm going to give it 1, and c is 4. Okay, so now b is 1, so 1 to the power 2 is 1, minus 4 times 4 times 4, so that's 64, I believe. Okay, so this is going to be complex number. Okay, so even though we have if statement and we have a message here saying there are no real solution to this equation, so if this happens, if we don't have real solutions, then we need to end this. We do not want this to run. So if we remove this, this is going to be evaluated to 1 or 0, okay, or true or false. And if it's true, then this is going to run and we are fine. Okay, it's going to display that. But what if it's false? If it's false, this program has to compute x1 and x2, right? So what to do? We use else f. So if b square is less than 4ac, then there is no real solution, so display this message. But if this is not true, then there is a real solution. We can use else f, and we have the condition. The condition here is going to be the opposite condition, right? So if this is true, then we need to run these statements. So let's run this again. It asks me about the value of a, it's 4, b is 1, and then c 4. So there are no real solutions and the program exits. Now let's run the same program again with other values of a, b, and c. So f script, this is a file name, and then run it, 1, and the value of b is going to be 4, and the value of c is going to be 1. Now b square is going to be 16, and 4ac is going to be 4, so 16 is larger than 4, and there are real solutions to this problem. So let's see. Yes, we have real solution. Now you can see that this message is not displayed because this condition here is false. Now else f here does require a condition. This condition is the very opposite of this condition, right? So in fact, we do not have to have this condition, and we can just add else. So if this condition is true, run this statement. If it's not true, then run these two statements. So let's try this example again. Okay, and then the value of a, I'm going to take the real and complex examples again. A is going to be 4, b is going to be 1, and c is going to be 4 again. Okay, there are no solutions. Let's take the opposite condition, f script, and then run. So a is going to be 1, b is going to be 4, and c is going to be 1. Okay, the solution is here. This is how to use the if statement with else f and with else. This solution contains a problem, okay, and I'm going to show it to you now. Okay, so when we run this script, we ask the user to enter a, b, and c. Okay, what if the user enters a value 0 for a? Okay, and then any numbers for b and c. So let's say for b we're going to have 6, and for c we're going to have any number 2. The problem here is in a. If a is 0, this is not allowed because now we are dividing by this term, which is 0. Okay, so a cannot be 0. So let's run and see what happens. We have for x1 nan and for x2 negative infinity. Okay, nan here stands for not a number. Okay, and negative infinity is like negative infinity. What to do in this situation? We have to control the input of the user. We can control it in the if statement. Okay, so in the if statement we can check first before this f a equals to 0. If a equals to 0, then we need to do something. Let's end it. Okay, we can just send a message to the user. Okay, so the message is going to be this. Okay, and then this is not quadratic equation anymore. Why is that? Imagine that a equals to 0. This term is 0, the whole term. Then the equation reduces to bx plus c equals to 0. So we can here comment on that and say bx plus c equals to 0. And then the solution of this problem is easy. We can have it as x1 equals to minus c over b, and that's it. Now we cannot leave it like this because f with n here is going to run, and then f with n here is going to run separately without considering that a is now 0. So we need to combine the two f statements. Now we are going to combine this one with the else f. okay, and then I'm going to remove and from here. Okay, so if a equals to 0, this is evaluated to 1, so we run this code. If not, then this becomes a quadratic equation because a now has a value that does not equal to 0 and it's multiplied by x squared, so this equation becomes this equation. So else if, this is the second condition, b squared less than for ac, we say that we do not have a real solution. Any other conditions that we have different than this one and this one will let us solve our equation. So there is a solution always whenever we have any condition different from this condition and this condition. That means we do not need a condition for the else. So this is how to use if with else if and else and end with a practical example. Let's run our script again. Okay, so enter the value of a 0, value of b 4, value of c 4. This should change to this. Okay, so this. Okay, this is not a quadratic equation anymore. It's a linear equation and x1 equals to minus 1. That's it. Okay, let's run another example. Okay, CLC, clear, CLC. Okay, so run it again. Okay, a non-zero value, so 1, b 2, and c, let's make it larger than b squared, so let's make it 7. Okay, so we do not have real solutions, we have solutions in the complex domain. Now let's take the next example. So enter the value of a is going to be 1, b I'm going to consider it as 4, and c is going to be 2, right? So now we have 2 real solutions, right? So this is basically how we use the if statement. Now let's have some examples on the switch statement. Let's write our code in a function instead of a script. So I'm going to have a new function. Let's assume that a teacher is trying to convert the grades of some students from numerical values to letter grades. I'm going to call this function grade to letter. When I double click here, so the first thing we do after creating a function is to modify the inputs and outputs. Here are the inputs, we're going to remove them, and here are the outputs, we're going to remove them, and we can remove the body. The input is the numerical value of the grade, so this is going to be grade. Okay, I'm going to call it grade. Okay, and here letter grade. Okay, so a teacher enters a grade, gets the letter grade. First, write documentation here. Okay, in fact, you can also use insert text markup. It's also documentation, and this is going to be auto-generated with MATLAB using this option. Okay, so we can have here document title. We are going to say this is grade to letter function. Okay. Okay, and here in the introductory text, we can say, for example, this function converts from numerical grades to letter grades. Okay, that's it. We can say here, if it's 95, for example, this is going to be A plus. If it's 90, it's going to be, this is going to be what? A. And then if it's 85, this is going to be A minus, and so on, etc., etc. If grade equals to 95, then letter grade is what? Is A plus. It's a text. Okay, this is a text, that's why we have it in single quotation. Okay, now else if grade is 90, then you copy that. Okay, A, and so on. So we can have several else if here, and we change it. So if it's 85, this is going to be A minus. And if it's 80, it's going to be what? P plus. Okay, and A plus, and then 75 going to be P. Okay, and 70 is going to be P minus. And you can continue with that. I'm going just to say else. Okay, so if it's 60, okay, or 65, I'm going to fail the student, so its letter grade is equals to F. So I just need to test it with those numbers: 90, 85, 80, 75, 70. Okay, now here I have F. Now I have end, so I have to have another end, which is the end for the function. So I have function end and F end, right? Now let's run this code and see how it works. Okay, so we're going to save it. It's saved already, so we just need to call this function with the number. So we can say grade 2 letter and then give it 95. Okay, so it's A plus. Okay, grade 2 letter and then give it 50. Okay, so it's F. Okay, that's it. Now I'm going to remove all of that and use the switch. In fact, switch is preferred more over the if statement in this situation, in which we have one specific value. We do not have larger than or less than. Okay, so it's better to have switch statement if we have equality. We're going to start with the switch keyword, so switch, and then give the variable name grade. Okay, and then what is the next keyword? Case. Okay, in case the grade contain the value 95, then run this statement. What is the statement? Put inside the letter grade variable the value A plus. Okay, and take the second case 90, then letter grade. I'm going to copy that because I'm going to use it a lot. So letter grade is A, and then case 85, then letter grade is A minus, and we can copy all of that, 85 and then 80, and then for 80 we're going to have P plus here, and then this one is going to be 75, and we're having P, and then for 70 we are having P minus, and we can repeat. So 70 is going to be here 65, and then 60, and then we're having 55. Okay, so 65 is going to be what? It's going to be C plus, and then for 60 it's going to be C, and then for 55 we're going to have C minus. Okay, and then case 50, this is letter grade equals to D, and then we can decide if the student gets less than 50, then the student fail. We can use a keyword otherwise. So otherwise means here for all other values of the numerical grade, give the letter grade this F. Okay, otherwise does not have a condition, or more specifically does not have a specific value for the variable. So this is very straightforward. It does not have any complexities. If a statement might become difficult sometimes or complex sometimes when we have nested if statements. We are going to cover nested if statements later in a different lecture. But for today, we have covered the very simple examples for the if statements and the switch statements, and we can just run it to check, okay, to check if it works. So I'm going to save this function and close it, and then call it grade. And when I hit tab, it auto completes for me, okay? And then it takes a number. So this number is going to be, for example, 95. So it's A plus, grade 2, letter, and then choose 35, and that's F, okay? So this is how to write the switch statement. And by this, we come to the end of this lecture. I hope you enjoyed it. I hope it was useful for you. If you like the content of this lecture, please share it so that other people can see it. And please subscribe if you haven't subscribed yet. Thank you, and I hope to see you next time.